Now we're going to work out the acceleration and the speeds of our exponential function. So the first thing I'm going to do is just note down on this page what my exponential function is so that you can follow along with me using your numbers. Now, don't forget that you will need to graph these functions in Desmos because you will want to compare your speed graphs so that you can tell visually as well which one is the fastest, which one is the slowest, that sort of jazz. Okay, so now I've got dt equals this as my function for displacement with respect to time. The next one that we want to work out is our velocity or our speed with respect to time. So velocity with respect to time is going to be given by the derivative of this function here. Now, I'm not being consistent with the way that I'm expressing this because I'm giving you options about different ways that you could express it. But remember, this isn't an assignment and you need to be careful and stick with one way. 6.605. Okay, so this is saying that the velocity is given by the derivative of this function. So now I'm going to take the derivative of this. Now, this constant on the end will vanish. This value above the e function will come and multiply that front value. So it will be 0.0133 multiplied by 6.605 e to the power of 0.0133t. And that's going to give me my velocity function. And that's going to simplify to give me 0.08804. Now, I've cut out some numbers. I've got it on a piece of paper next to me. Just remember to be consistent with your rounding. Okay, now, just while I'm in the mood for deriving, I'm going to go ahead and derive this again to get my function for acceleration. So the acceleration with respect to time is given by the derivative of this function above. So this one here is what we're taking the derivative. So I'm going to take the derivative with respect to time, bracket 0.8804 e 0.133 t. Again, this number is going to come down and multiply that number. Now, in your assignment, you would show that working of this times that gives you the next row. Me personally, though, I'm just going to skip straight ahead to the answer. So when that displays in my calculator, and you might have this problem too, it appears as a number that's 173653 times 10 to the power of negative 3. So just remember, with your scientific notation, it tells you which way to go and how many times you're jumping. So positives get bigger, negatives get smaller. So I'm going to go this direction for 3 spaces. 1, 2, 3. My 0, it goes in the front, and I fill the other bits in with dots. So the number that I can write down for that is 0.001736. I'm going to cut it off there. E to the power of 0.0133t. Now, you could just leave it in scientific notation. It won't change anything. You can put it in Desmos' scientific notation as well. The computer won't mind. Okay, but the problem that we have with this one that we didn't have with our polynomial function is that we need to be working out our 5-minute splits. Our time for that. So we are now going to pause, and I'm going to think about what happens next.